Data is the new oil.
Hey, if you're in the business of selling data tools, and I think it's a great idea. You just need an engine to put it in.
Right.
And the problem is most people. Well, you actually need a person who knows what to do with oil.
Right.
And that's the problem. We don't know. We know how to refine oil. We've been on it for a long, and we know the purpose that it's for.
Of course,
it's a very simple purpose. But data's not like that. So like all good buzzwords, it's a great pitch if you're in the data science, right?
Right.
But the reality is most people don't have a clue what to do with data.
Right.
Most computer scientists don't know how to write a decent query. How many of your programmers really like to program in SQL?
I know, right? That's right. Yeah.
So I've had them from second year. Seymour Cray had a great expression.
Right.
He rented the Cray computers, of course, and he said, hire engineers young, they don't know it can't be done. And I found that the best place is they start with a second-year student. First-year students too much of a pain. They just got to get used to university. Start with a second-year student, and you can get them to do almost anything because they're so excited and they're so open-minded.
Absolutely.
You get them with a master's or a PhD, and all they want to do is whatever they did for their master's or their PhD. They get very narrow-minded. So, I'm a big fan of hiring young people and then having them with you for a few years. And that way you tell them how to do things wrong your way, as opposed to them telling you. But, it's an incredible experience. I mean, I can't tell you how much I've learned from students. In the end, I think it's very enjoyable to solve other people's problems. And that's, I think for me, the most exciting thing about computing has been able to help work with people that I know absolutely nothing about what they're doing. And I get to learn all these things from them without really contributing any knowledge myself other than how to put some fairly simple software together. And it's been very exciting. I mean, I really enjoyed my work doing simulation with biologies and people in transportation planning and command and control. Just wonderful opportunities to learn about all these things.
Yeah.
And I really can't write software for myself. Like I don't play computer games. I don't find those things, I don't find programming just for the sake of programming particularly interesting, but I find it really exciting to be able to work on someone's problem.
Hey everyone, welcome to today's episode. We're thrilled to have a pioneer, a veteran of the software industry with us, Dave Thomas. With a remarkable career spanning decades, Dave has worn many hats: executive, investor, board member, consultant, architect, and engineer. Currently, the chairman of Bedara Corp, Dave continues to shape the future of technology by offering strategic consulting and providing leadership as a virtual CTO and advisor to emerging technology ventures. But Dave's journey goes far beyond titles. As the founder and former CEO of Object Technology International OTI, now IBM OTA Labs, that has acquired it, Dave revolutionized the software world with his visionary approach to the object oriented technology and agile product development. His leadership at OTI introduced the concept of just-in-time software, and his groundbreaking work laid the foundation for tools we now take for granted, such as IBM Visual Age and the Eclipse IDE. Dave's impact extends globally as the founder of renowned Yo conferences, where he continues to inspire and nurture the next generation of IT leaders. His enterprise as a keynote speaker, known for his humor and keen insights, has made him a respected voice in conferences like Agile Development Conference, Oops LA, and many more. With close ties to academia, as an adjunct research professor at Carleton University, Dave has maintained a deep connection with the research community, turning innovation into real-world success stories. From founding Bedaro Research Labs to playing key roles at KX Systems and pioneering virtual machines for embedded systems, his contributions to both business strategy and technology development are truly unparalleled. In this episode, we'll explore Dave's extraordinary breadth of business and technical experience, his life, his visionary thinking, his relentless drive to push the boundaries for software engineering. Get ready for a conversation with the thought leader who has not only witnessed evolution of tech, but has also been at the very helm of shaping it. Let's dive in. Welcome to the Pathfinders, Dave. So happy to have you today.
Oh, thank you, Vijay. I'm embarrassed by that long, very gracious introduction. You could have just said software fossil, and that would have worked just fine. Great to be with you.
Oh, thank you so much, Dave. So, Dave, take us back a little bit. Please, can you share us a little bit more about you, Dave? So, for anyone listening, they'd love to know a little bit more about you from your own in your own words.
Oh, I was fortunate to fall into computing as an undergrad. A friend of mine was a business student, and they had to do this horrible stats project right in the middle of ski season, and so. He came to me and he said, we need help. We want to go skiing. We've got all these numbers we got to punch into calculators. I had to punch them into calculators. And the profs have already told us that they check if it's done on a computer because they can tell whether it was done on a computer or not. They could tell because you get floating point numbers.
Right.
And so I said, well, I think I could do something about that. And the machine we had at the time was a very old IBM 1620, and you could actually program the arithmetic on it, so it would do decimal arithmetic exactly like a calculator.
Right.
And so for the rest of my university days, all the students came and delivered their data to another student of mine who I had run the operation, and that was basically my first commercial venture in software. So right. I did an undergrad in electrical engineering, and I have to say I don't know much about electronics, which I'm embarrassed because my father was very good at electronics, but I fell into software.
Right.
And was very fortunate to get a job at the University Computer Center. And in those days, this was 1969.
Right.
A lot of the interesting software work was done in the computer centers. That Simula 67, for example, that language was done in the Norwegian computer center. So it was a place which did a lot of the work on languages. So I was fortunate to work there and then get involved with a bunch of the computer vendors, work on a lot of their compilers and runtimes and some of their databases, and because I did joint work with the universities. And so that was an opportunity. I went back to grad school, ended up getting a position in the School of Business as a result of the dean of the faculty who heard about my venture with his students and wanted to meet me. And he says, I understand you've been making a little money off our students. And I said, yes, professor, I have. He says, what do you charge? And I told him the price. And he said, well, do you not think you could put it up a little more? I said, I probably could put up a few dollars, but I don't think that's fair to the students. Anyway, we developed a great friendship, and he had me come to the business school to start to sort of fix their IT program. And from there, basically, I went off to industry and did a lot of work on microcomputers, microcomputer network, a lot of work on programming languages. And then they decided that they wanted to form a school of computer science. So myself and 4 other colleagues basically put together the first school of computer science at Carleton University here in Ottawa.
Right.
and I moved to full-time to computer science. So from engineering to business to computer science. And I think I
Right.
would have gone to biology because that seemed really interesting, but I ended up doing startups from then on. So
Right.
first startup was doing retail point of sale systems. And then the other ones were involved in doing microcomputer networking. And then I got pretty much into the programming language rut.
Right.
Did a lot of work on Scheme and
Yeah.
other languages, then Smalltalk, then Java, and the rest of the story you've already bored people with. Now
Yeah.
I've bored them with the beginning part.
No, they always say computer science is the field of study, and when you actually commercialize it, that is the software engineering. When you create a product with it, like what inspired you to get into the world of like software engineering and the tech?
I think, I love problem solving, which I think is what takes you into engineering. You like
Right.
making and breaking things.
Right.
And I think once you're in engineering, it just happened that the thing that I can make and break the easiest was software.
Right.
So I think I was there. Electronics, I can remember struggling for some of those things. I basically had the wrong voltage and burn out some of the parts, and
Right.
so software was much easier to fail, and much gentler
Right.
repercussions. So I think it was really that. But I think the benefit of engineering is, although there are lots of people who basically say that software is gardening or software is whatever
Yeah.
you want to do. I really believe that software is engineering, that
Right.
you go through the same kind of disciplined thinking and challenges that um, engineers do. I'm not hung up over whether one's an engineer or software engineer or a
Right.
computer engineer or a computer scientist or an IT professional. In
Right.
the end, I think it's very enjoyable to solve other people's problems, and that's I think for me the most exciting thing about computing is being able to help work with people that I know absolutely nothing about what they're doing, and I get to learn all these things from them,
Right.
without really contributing any knowledge myself, other than how to put some fairly simple software together. And
Right.
um, it's been very exciting. I mean, I really enjoyed my work doing simulation with biologies and people in transportation planning and command and control. Just wonderful opportunities to learn about all these things.
Yeah.
And I really can't write software for myself. Like I don't play computer games. I don't find those things. I don't find programming just for the sake of programming particularly interesting, but I find it really exciting to be able to work on someone's problem for them.
Right. Right. Got it. No, thanks for sharing that. I mean, yeah, I can't wait to get into a lot more. I have a lot many other topics that I want to get in. But like, what was your like turning point in your like 40, 50 year long career that like shaped actually the trajectory that you have actually picked up? Like, what was that turning point, you would say?
I think it was formed very early. I became, one of the things that was easy then is there were only like 4 books.
Right.
So you didn't need to you didn't need to have a lot of bookcases full of books and everything like that, because there were
Right.
only 4 and they were really good. I just bought one of them back because I lost it. It came from a rare bookstore. Um,
Right.
so I think that was one, and I think I was really lucky that I got very interested in programming languages, and
Right.
I had jobs that involved sort of automating programming,
Right.
and uh, I think, and
Yeah.
I got, I think in my my first summer job, I was doing nonlinear hill climbing stuff, the sort of thing that you do with neural nets, right? It was,
Right.
uh,
Right.
except much slower and, not like with the elegance of today. And so I learned a lot about sort of mathematical programming and so on. Then my next job, I was doing simulations for modeling airports, and we learned a
Right.
wonderful language called SimScript. We learned all about simulation and modeling, which is good. So I really got hooked early on these programming language things. And when I took the job as in the computer center at the university, I was in charge of the scientific computing sort of support team. So we had
Right.
responsibility for all the different programming languages and tools and so on. So I think
Got
I
it.
just fell into that. and I haven't fallen out. Right, my passion is how can a small number of people build interesting software quickly, and I'm still chasing that dream. I'm not there yet.
Yeah. No, you bet. And then for the purpose of like anyone listening, what are the like 4 books, like if you remember top of your head? Because today there are like thousands and millions of books. And what were those like 3 or 4 books that you remember top of your head that like anyone listening can still go back and then probably
Well,
peek into?
I'll give you more modern ones that people can easily get. I mean, one of the key books for me, and we used it as a major filter for hiring, for example, when working with people, is a book called The Structure Interpretation of Computer Programs by Abelson and Sussman, which was at one point the MIT first year book. It's the schemes book, or some people call it the wizard's book. And that's, if you really, people who have read that book understand computation and what languages and bindings are all about. I think the other ones are kind of like Knuth's books on algorithms, or the follow-on, of which there's many. And then I think things like Fred Brooks' Mythical Man Month, which really talked about the big software issues like, don't add more people to a project, which many people still don't accept, right? They don't understand there is a software physics, oh, how many more people would you like, I think those were the big Psychology, Computer Programming, also mentioned by Jerry Weinberg. They're 2 very old books, but they cover the kind of the soft side or the issues, and they deal with almost all the issues that a lot of the things that came up in Agile and other things later. I mean, Jerry Weinberg basically said, we had terminals in the old days, not computers. And he said there should be, at least, 1.5 persons per terminal, which is kind of the whole notion of this is pairing, right? The fact you don't want to be hand in hand at 2.0 where you're there all the time, but some of the time you want to be, looking at the code, whether it's just reading the code, debugging, designing test case, but you want to be working with someone else to bring out the code and understand it.
Yeah. You've actually throughout your career, I'm sure like you've held multiple roles, like from executive to investor to professor to engineer. Like, how are you able to like balance these like different facets, like in throughout your career?
I think one of the key lessons is when you go do something new, it's natural to be terrified, and to have the imposter syndrome. But that makes you work really hard. I mean, when you have to go into that classroom that teach that course, you realize all the things you don't know about that course and that material, right? And you're sitting there sort of, facing the board, and you get this, bright young students ask you this question, and you realize, oh my God, that's a really deep question. You sort of panic, make it to the end of class, then run home madly so you can get ready for the next few lectures. But it's surprising how much, if you let the mind work, it does a lot of things, and you often seem to know a lot more than you really think you do. So I think it's just, and the other thing is, of course, mentors are very important. And I was very important in me in every transition that I was able to work with outstanding people. I mean, I would not be, teachers have a huge impact. I had 2 teachers in high school. I had 4 professors in university, in different faculties, all of whom were instrumental in my career decisions. And when I needed to find out, I mean, it's very difficult when you find yourself as a first time faculty member on a tenure and promotion committee, which is going to determine someone's, more than several people's future, to be able to do that. And certainly without the wisdom of a couple of senior professors, I wouldn't have been able to be on that situation. The same thing when I was in a software engineering organization, having the advice and benefit of other people who'd done, as I like to say, I've done more things wrong than anyone else, so I can share that with you. That's called experience, right? So, if you could give people a needle for experience, that would really fix everything, right?
Right.
So,
I mean, yeah.
being
Sorry, go
able
ahead.
to get that compressed experience
Yeah.
from others is very important, which I think is why a mix of people with different backgrounds is very important. I mean, our fledgling computer science department was very interesting because the people in it were not computer scientists.
Right.
Right? They came from engineering. We had one computer scientist. We had a logician. We had a mathematician.
Right.
But we shared a lot and we learned a lot from each other because we got this view into other
Yeah.
people's approaches to things, and that's just a wonderful way to approach problems.
Yeah, yeah. I'm speaking of experience and advice. I mean, like having known what you've known, like after like spending 50 years into the industry and career, like if you look back and if you had to go talk to your younger Dave, like what would you tell him?
Well, I think we're just on the I'm glad I don't have to answer that in 5 or 10 years. Given where AI is and its unpredictable behavior. But I think
Right.
uh, the most important things, uh, focus and discipline,
Right.
very important. Uh, Learning from others, so older or colleagues. I mean, I'm sure as a university student or working, you have the experience where, wow, I'm really glad I'm working with Paul or John or Mary because I wouldn't have figured that out alone. Collaborative problem solving is just a privilege to be able to work with others.
Right.
I think having a really good understanding of computation is really important if you're going into if you're really going to go into sort of deep computer science, if you want to work in runtimes or programming languages or high performance messaging or hardware and I think that's something that a lot of people miss now because they've got so many other subjects to take and so
Right.
many languages and so on. The fundamentals. That's why I mentioned again the Abelson and Sussman book
Right.
because I think that's basically, I think most computer science could be taught with those 3 or 4 textbooks I mentioned, and you don't really need the
Right.
other ones nearly as much. And so,
Right. Right.
I think the other thing that's very important today is experience. And one of the benefits we have in Canada, as you know, is we have something called co-op education, where students spend
Right.
4 months, four
Right.
to 8 months working and get paid. And
Right.
I need to mention that because lots of places they don't get paid and then they go to
Right.
school for 4 or 8 months. And so it takes
Right.
you 5 years to do a 4 year honors degree, but you graduate with 2 full years of work experience. And certainly, I think almost all the employees for the last 20 or 30 years I've had have come
Right.
from co-op programs. So I've had them from second year. Seymour Cray had a great expression.
Right.
He rented the Cray computers, of course, and he said, hire engineers young, they don't know it can't be done. And I
Right.
found that the best place is they start with a second year student. First year students too much of a pain. They just got to get used to
Right.
university. Start with a second year student, and you can get them to do almost anything because
Right.
they're so excited and they're so open minded. You
Absolutely.
get them
Yeah.
with a master's or a PhD, and all they want to do is whatever they did for their master's or their PhD. They get very
Right.
narrow minded. So
Right.
I'm a big fan of hiring young people and then having them with you for a few years. That way you get them, tell them how to do things wrong your way, as opposed to
Right.
them telling you. So, but
You have
and it's an incredible experience. I mean, I can't tell you how much I've learned from students.
right. Right. Yeah, I cannot help but notice, but you have like you have something that's a acquired instinct in terms of like when people say humor and self-critiquing is something you're always inspired from others. Is that something that you're inspired from your grandfather or father? Because you have a very humorous way of putting things. At the same time, you're a very good self-critic as well. Where did that come from?
Perhaps I get some of it from my father, but I think
Right.
it's one of the problems is you get these overinflated I put my pants on one leg at a time, just like everybody else, and I think
Right.
just because I've been fortunate, and certainly I have, I mean, I've had my good fair share of luck. And I think it's important. I think most people who have been successful in some dimension, have that same luck
Right.
and appreciation for the people who help them and want to pass it on. So I think
Right.
it's important to for people to have a feeling that you're actually a human, even though you can
Right.
be an opinionated and difficult person.
Right. There you go again. I love it. I love the humor part, and especially when you're critiquing it, you don't take yourself as seriously as many others do. So love that part. So I cannot help but notice, and have to mention it.
My brand will definitely fall off. It's not stuck on well at all.
There you go. I mean, from your personal life to your professional journey, and like, were there moments like where the personal life shaped the other, or the professional life shaping the personal one? What was it? How was the overlap? Like, how did you navigate the personal and the professional journey?
Well,
And what was your take on like the work life balance, as they call it, quote unquote? It has taken different forms, but like, what is your thoughts on that?
well, I think I was very lucky. I met my wife, who's did a nursing science degree um, in my last year of college. Um, we, were married a couple of years after that. Uh, Anyone who knows her say that's the reason he's anywhere. You should have seen how bad he was before he met her. Um, and she's an amazing wife, mother, and grandmother. And I attribute a lot to the fact that she provided a stable environment. I mean, when we did, um, first of all, I left the university to start a company,
Right.
which was, I was a tenured professor, leaving a pretty good job. I mean, you know a very good job, and I went to the bank and took the house that I had paid off and mortgages to start OTI actually,
Right.
and I think that takes a great deal of understanding and trust. She did
Right.
say to me, I now own half of it, right?
Of course.
And
Yeah.
actually, when I sold it, I gave half the money to the employees, and I got a check for zero, and my wife got a check for half.
Wow. Yeah. Yeah.
Um,
Very interesting. Okay.
so, and I think I was fortunate. I was fortunate to teach because that being a TA and teaching, and then being, eventually getting to be a professor, basically helped a lot for being able to speak in public before companies and talk about products or technologies and so on, and also to speak at conferences. And
Right.
if you're early in technology, speaking at conferences that are leading the conferences are very important. I mean,
Right.
OOPSLA and eCoop and things like that were absolutely essential for us to establish ourselves here in Ottawa. Who are we?
Right.
What do we know about objects and so on compared to all the smart people in the world? So the
Right.
fact that we were present at the table really, really helped.
Right. Right. Just give me a second. I'm just going to close the window. It's getting evening and it's getting colder, so I'm just going
No
to close the
problem.
window. Yeah, sorry about that. So,
Huh?
in terms of like from technology and innovation, and you have been at the forefront of some groundbreaking developments throughout your career: Visual Age, Eclipse, Smalltalk, JVM, Java Virtual Machines, and like uh, there's so many, right? I mean, so many didn't make it to the list, but you have so many, I'm sure. Like, what is something you're like the proudest one, the proudest technical achievement you would call it?
Oh, I don't think I've been really. I could probably maybe talk about some failures, but I I think they each had their own different dimension to them, and
Right.
so each of the things I worked on, um, the people I worked with in all those cases were tremendous. I've been very fortunate to work with outstanding engineers and
Right.
really quite humble people. And they were different
Right.
enough, the experiences. Um, I couldn't single out one or the other,
Right.
but I could go through a list of what's wrong with all of them.
All.
The, just in case anyone is confused that they've just built the most beautiful thing, I can assure you, a few years later, you'll
Right.
be embarrassed to have your name associated with it. So don't get it branded inside it. Someone will
Right.
show it to you again in 20 years. My grandson is now using Eclipse, and I had to apologize to him.
Love it. Like in terms of like object oriented technology, like how do you see the role of like object oriented tech in today's software landscape?
I think it's very useful still, but objects are a modeling technology.
Right.
So the problem is when we get a new technology or a new language, we tend to treat it as the hammer or the thing that will kill everything else. So instead
Right.
of sort of saying, "Oh, this presents a new way for me to model," if I use objects to model the world and model things, we have to turn
Right.
everything into an object. I mean,
Right.
and the big failures of object technology is trying to turn data, trying to turn rectangles into round things, right? I mean,
Yeah.
object databases were a failure. Object relational mappers were a failure. They were just a
Right.
bad idea because data is rectangular and objects are round, right? One,
Right.
fights the garbage collector. The other one, just moves swiftly and, through the machine. So
Right.
I think it's appreciating for every new technology what's new,
Right.
also, appreciating what's old or came
Right.
before, and if that's been elegantly placed together. So
Right.
today, my favorite technology is vector functional programming, which
Right.
is quite rarefied air that not many people, want to go near. But it's an amazing technology, both in terms of speed and the small amount of code you have to write, hyper
Right.
productive relative to. But there are you have to cross the learning curve to get there because it's different,
Right.
and you won't find your favorite things that you're used to using
Right.
in that world. I think the big problem is that basically libraries are so terrible. So the
Mm.
languages themselves are you can move fairly quickly. I mean, if you have a reasonable understanding, you can move between a functional
Right.
language and even a logic language and an object-oriented language or a procedural language. Yeah,
Right.
the language has good syntax and semantics. You can pick that up pretty quickly. Even though
Right.
logic programming is quite different, you still can get there. But the thing that really kills you is you've got this huge personal investment in the libraries.
Right.
So people can't move from Smalltalk to Java, not so much because of the language difference, but
Right.
because of the library difference. So people are so heavily invested in libraries. I mean, are you ready for React 22? I mean,
Right.
no. What the hell do you mean? They can't change React. I've invested 5 years of my life in this
Right.
version. And so now
Right.
the GPT may save us there because GPT is going to invest, all of
Yeah.
its machine cycles in trying to figure out what all those crazy APIs are.
Yeah.
But so the real problem is the languages are the languages that are causing the problem are the APIs
Right.
because they essentially extend what you have to do to write programs.
Got it.
And so I think
Got it.
that's one of the frustrations today. In the old days, which was nice, is you didn't have hardly any APIs. Read, print, write.
Yeah. Yeah. Yeah.
You
Pretty much.
yeah, and so it was a lot easier to program. Now it's very
Right.
hard because you have to spend so much time. Like, oh, what service do I need? I'm using Amazon. Here's another, 300, APIs sorted alphabetically for me to figure out what I'm going to use. Right? It's really hard.
Right. Right.
So
Right.
I think a lot of the challenges come up not because of the language per se, but because of but I am very partial to exotic languages.
Got it.
So things like Smalltalk or Erlang or
Yeah.
K, these languages which are kind of pure in a sense that they take. I would say Haskell, although I'm not a competent Haskell programmer, but languages which take a strong position that says everything is done one way, because they force you to think very cleanly. And then to me, the right thing is to have a very good interlanguage interface or foreign function call, or what do you want to, so that you can use the right language for the right job.
Right.
So I really think that's, we want less in the libraries, more in the languages, and more interop between languages. So,
got it. When you were building OTI and in your periods of Visual Age and others, like obviously, I'm sure there might have been resistance and there might be challenges in terms of pushing object-oriented programming to enterprises, to developers. Like, how did you overcome that kind of resistance and basically helping scale the adoption of object-oriented programming?
I think after a while, you learn a few tricks, and one of the ones is not to be with the zealots. Right. So you have to position yourself away from the zealots, because they're the ones that drive everybody crazy. So if you don't have to talk about Agile, but you just do it, people are much more receptive. Right? You don't yell at everyone and say, "Look, you're not using velocity," right? Which is a stupid idea anyway. But so you get the problem is that people get on a new technology, seem to get on this attack vector, and want to kill everybody else that's not using it. So I think one of the things is kind of respect. Say, look, we're just building software. This is the way. And when people ask, I would talk about object-oriented design and programming and how to build with components and so on. I never mentioned a language.
Right.
And at the end, people would always ask, well, what do you use? And I would say, I use Smalltalk. And they sort of look at me. What? Smalltalk? I said, yeah. I said, we use it for this reason. It's the fastest way to do things. It's the most mature environment with all the tools. And, it's just faster for us to do it. And they said, well, aren't you worried about, going out of business? I said, no, there's multiple Smalltalk vendors. I said, there's only 4 or 5 C compiler vendors. When you get down to it, there's only 2 or 3 C compilers that anybody in the world will use. So you actually have the same liability in the sense of the number of suppliers. And the other thing I said, well, Smalltalk's really just a C program that interprets some rules. Which is true at a certain level of abstraction. So I could make people comfortable with the fact. And when we built the Tektronix oscilloscopes back in 1988 with the help of Rebecca Wursbrock and Ward and a great team at Tektronix, Kent, I think, had just left at that point back. They basically said, well, could we actually get Smalltalk inside an oscilloscope? I said, of course. But the first thing we did was actually output from the Smalltalk uses an image or like a workspace. The first thing we did is we wrote a thing that crushed the workspace and produced binary S records, which you give to a ROMer if you're going to make ROMs. So we basically took a Smalltalk program and put it in ROM, said plug it in. And at that point, the engineers at Tektronix said, we're all in. You can call C code. You can, put it in ROM. So away we go. And, the biggest challenge we had with Smalltalk actually was we had to build a fine-grained versioning environment, kind of the Git, a Git for Smalltalk, if you think of it. Because that didn't exist. Smalltalk programmers all in those days were like Lisp programmers. They all worked in their own workspace, and they didn't share. Everything was in their workspace, including their lunch bag from three years ago, right? So, so the challenge when we did something called MV Developer is team programming environment, which we wrote up at OOPSLA, something called Orwell. It was very Orwellian for object-oriented programmers to actually share things. So what this does is put them in a shared world. Actually, very similar. Actually, it was partly an inspiration for some of the work at Unison that Runar has done. I know you've interviewed him. Have you talked about Unison at all?
No, I had those questions like, who are the next people I should talk to? Maybe I'll take that list from you, but definitely would love to talk to him.
Definitely. It's very interesting language, but the environment design is very interesting. But anyway, the challenge we did, and the thing that really made us successful, and we made most of our initial product success, was not doing Smalltalk itself, was doing this distributed environment for version control. So you could version any method, any class, any package independently, both the source and the binary, and transfer them between machines. So it made it very productive for a group of developers. Otherwise, you had this single machine, you had to push the source out, load the source in, very cumbersome. But this allowed you to basically have shared workspaces that do this. So
got it. Yeah. I mean, like, how do you, in terms of like when people come from like non-OOP standards, like for example, they have been writing program in C or otherwise, like very flexible, like very simplistic according to them, but at the same time OOPS brings a lot of like structure in terms of inheritance, polymorphism, object hierarchies, and lot of that. Like how do you how do you argue with them and then say, hey, no, you have to transition to a OOP based model, like that is the future you have to look into. If someone were to argue, no, mine is a simpler version and it's much flexible to maintain, how do you argue with them?
Well, I think there's only two ways that these things go.
Right.
You know, if it's the CTO that's saying, I don't believe in this technology, and you're in front of a big group, you have to kill him.
Right.
I mean, basically, you have to just take all his questions and decimate him. That's very risky. Right. I don't recommend that strategy. But when you're attacked, you really don't. You really can only duck humbly, and then the third time you're attacked, you have to attack back. But if you're talking to someone who's open-minded, you can show them the similarities and the differences. The other thing is you don't tell them about everything in the kitchen sink to begin with, right? I mean, you show them, and I mean, methods are no different than functions, right? So I think you need, and the other thing, you need to show them examples where it's bad, right? Like here's a good example, where there's no objects in this, right? Yeah, this is just data. These are just records. Don't make them into objects. That this is a mistake that this object-oriented person over here would. So, by again having a little humility with respect to your own technology and showing out this is a bad use for it and why it's this is not doing object-oriented programming, and your way of doing it would be better for this, right? So I think respecting those things is the way, and having the conversation and finding the common points. I think it's no different than other. Are you interested in having a conversation, or are you interested in just killing them? Right.
Right. Of course. Of course. Something came from like my personal conversation from few other technologies, and I was having this impression. I shared that with one of the fellow technologies, and like my experience was like from basic to C programming to C++ to Java, J2E, then .NET, and databases and whatnot, right? So the reason I shared that like curve is because like I was able to understand C and appreciate C better when I learned C++. And I was able to appreciate like C++ better when I was learning Java. And likewise, when I went to J2E, I was able to appreciate Java better and then C++ better. Why do you think that exists? Because like when you're actually learning that language, I was able to appreciate it when I moved on to the next thing and started learning Java. I was able to appreciate C++ better. Why do you think that exists?
I think it's natural because you see things that you would do quite straightforward ways, or that would work much faster or much smaller than when you're using the next technology. I guess the difference is when we introduce people to a new technology, I try and introduce them to the clean one. So if someone wants to learn objects, I like them to learn Smalltalk because it's much simpler and doesn't carry all the baggage. You don't have to have left-right inheritance and meta programming. I mean, and if you're doing functional programming, then I like Scheme, but I'm slightly imperative. But Haskell would be the other choice because you can only do it their way, right? So you're not in a kind of mix. So you really get that fixed approach, right? And so I think if you learn in the sort of pure language world, you get to understand what the language is about. And then when you pick up Scala or whatever it is, because these other languages mix a lot of things, F sharp and so on. They mix, F sharp is
of course,
OCaml sort of on, on .NET. But I think it's hard I think you had the hard way because you went from technology with these big libraries.
Right.
And that's the problem, right? Well, where's the, MVC thing here? What do I know? J faces, what is this? Or what, pick whatever so I think, learning the concepts separate from the particular technology, I think is useful because you can do that in a week or two intensive course.
Right.
And people really get the idea.
Right.
And then you can say, okay, well, now you're going to use the real thing. So there'll be 47 ways to do things and the syntax will be a lot more complicated, but it's the same idea. Just, this is commercially the way we do it with this messy stuff.
That's right. That's right. You've always advocated for functional programming, right? So, like, how do you see functional programming improving or enhancing the future of like software development practices?
Well, I'm an advocate for clean, efficient programming languages that are safe. And acknowledging that there are some times when you need to write low-level code where it's difficult to have safe code. But I think depending on your problem, I mean, if you're working in a world of algorithms, largely, most algorithms have reasonably formal, mathematically inspired roots. So a language which allows you to express those things without having to go too far from that expression is quite natural. I mean, most mathematics doesn't have objects, right? So, why should I worry about them? You can think that mathematics has types, and I won't get into that argument, but the types are certainly useful. And basically, type checking is the big contribution of formal methods to software thus far. So I think, I'm not a strongly manifest types person because I'm not smart enough to get the types right. But I like dynamic language for thinking. But I think that you really want a type system where you can sort of dial it up, right? I want it loosely typed, or dynamically typed when I'm thinking, and then when I'm getting to the end, I want to be able to turn the knob and say, tighten the types down now, start checking this thing for me. We don't have, Gilad Braki wrote a wonderful paper on pluggable type systems, which don't exist yet, but maybe one day we'll have something like that. But so I think, functional programming is very good and for data. I mean, if you want fast, high performant data, both lazy evaluation and having everything be vectors, it's basically the sort of fastest way to go. So I think if you're doing that, most machine learning stuff is all, vector math. And so, if it suits the problem, that makes sense. Now, one of the things I have seen, for instance, is people take a functional language and try and do something that's very computationally fast with a lazy language. And lazy languages can be fast, but it's hard work to get them that way. And so, but what I've seen is people do a different trick is basically where you build a DSL in, say, Haskell, and then it generates a C++ program and it actually does all the portfolio calculations and so on. So again, functional languages are very good for thinking, even though you may not be able, two friends, Brian and Eric Meyer, both basically they would use Mathematica with one hand and C# with the other, and use the results from Mathematica to test their C# code and things like that. So I think it's really having an appreciation for this is another way for me to look at this computation, to look at this. And writing the program twice in 2 different languages is a very good way to get a correct program.
Right.
Or having
Very,
two or
very
three people
interesting.
write the same program. That's
Right.
look. I don't want to get into a discussion about
Yeah.
TDD and how it's jumped the shark, but
Right.
I mean, all you TDDers, please find out about property-based testing. It's way better.
Right. Right. No, I know. I definitely appreciate that thought because, like, when you're trying to bring multiple teams, especially from multiple organizations, they have a different way of doing it, different SDKs, and if you have to agree on a common contract or an API, and definitely coming from different approaches, we can really real time test it, what's working better than the other, and you're able to optimize over a period of time as well. It's a
Yeah,
good way to optimize tech also, I
in
think.
principle, mocking is sort of the lazy man's. I'm not going to write the whole thing twice. I'm just going to write the part that I think I need twice. Right?
Right.
But I think that's one of the things. I mean, I think most programming now with LLMs, most programming could just be pseudocode.
Right.
You just write the pseudocode, or you just tell it to ChatGPT,
Yeah.
and then say, "I'd like this in whatever funky
Yeah.
language I want," and it works pretty well, actually. I
It
mean, it's
does.
getting
It
better and
does.
better,
It
and
is.
so um, I don't think the future is program is. I don't know whether you've seen any of Eric Meyer's recent talks, but
I have to watch it.
I'll send you the link.
Sure.
But I think a lot of people assume that the future is Copilot or things like Copilot, Cursor being the hottest thing
Right.
today.
Right. AI Copilot. Yeah.
But that sort of writes the code for you in the language you're using. But the approach that's advocated by Eric and others, in which I've just talked to another friend who's working in that style, is
Right.
basically they believe that what you should do is just program with the LLM. So the LLM
Mm.
basically does it, and you use the LLM as essentially the programming language and the environment.
Right.
And
Right.
you don't worry about trying to generate some other terrible language. You rather have a
Right.
language that's in the LLM, which is safe, which is known and much simpler. And because you can talk to it in natural language, you don't need all of the mechanisms that are in there, like
Right. Right. Speaking of the landscape, and of course, we're talking about AI and LLMs. And like speaking of the landscape, like when you started out, how do you see the major differences between when you started out versus like what tech is evolving into now into a behemoth monster, into AI, cloud computing, and blockchain and whatnot? How do you see the differences happening real time?
Well, first thing is that things don't really change that much. So, and the second thing is they change a hell of a lot. But
Right.
the question is, do the important things really change? I
Right.
think the thing that's happening really fast is a lot of code being written by way too many people, and
Mm.
that's why we have all the problems, in my view, today. Basically, people writing
Right.
too much code without understanding the domain, uh, without having the ability to probably test that code or the time. I mean, there's pressure, all sorts of things. I'm not faulting the
Of
individuals,
course.
but basically, we're writing way too much software. And when you get
Right.
Copilot, it's going to write at least 30% more than you could write, maybe two or three
Got it.
times that. So the problem is we have too much code. So the real
Right.
question is, how do we get less code? That's my thing. And so I think the things we need to think about is, why are we making things so complex? I mean, if you look at,
Mm.
there's I'm sure you've heard the name Karpathy, Andre, who's, did the LLM Llama C. I think it's, 900 lines of C code that basically competes with the GPT-2.
Right.
Yeah. Well, there are people who've done it much smaller than that now.
Right. Right. I
Yeah.
mean,
So
yeah.
the question is, um, and this causes you to ask the question: what the hell is PyTorch doing anyway? All right,
Right.
and what is all this stuff underneath me? And
Right.
that's one of the problems as well, is that um, most of the good software developers I know don't have that many bugs in their own code. They
Right.
have bugs wherever they talk to somebody else's code.
Yes.
And,
Yes.
and, that,
Very
and that
true.
could be because they're not talking, they're not using the right API with the right
Right.
parameters. They haven't configured the right resources.
Correct. Correct.
Configuration files are. I mean, it can still be their fault,
That's right.
but
Yeah.
the it's not. It's very
Boundary
seldom that
conditions.
in my experience, that you know, the bug is in the code you own.
Right.
Right. It's
Right.
in code that you may own, but it's touching something else and it's biting you. Right.
Right.
And that's because there's too much and the APIs come out too fast. I mean, you shouldn't be allowed to just print APIs by the millions, right?
Right.
And they don't even come with examples that work, right? The people
Right.
are, you go to meetups just so you can learn what the new API for JavaScript, 4.2.9 React 12, right? I mean, yeah.
Yeah. Yeah.
And people are constructing examples, right? So, so the GPT can learn them, right?
That's right.
And
That's right.
so these are not so APIs are not well designed languages, but they are languages. And
Right.
that's you need to think about them that way. So, we need to be simplifying the code instead of growing it. The reason we have such a big mess is we have
Right.
way too many people writing way too much software.
Right.
I'm not going to change that. I know that. So I'm not on a religious campaign, but
Yeah.
I mean, I think
Uh,
that's the problem. And the cost of writing bad software, there's no penalties, very little penalty.
got it. Got it. So, I mean, looking into the future for the next 5 or 10 years, what do you think would be the upcoming technologies or trends that'll be making the most significant impact? One, I'm sure we spoke about Copilot and LLMs. What other trends do you think would be making a larger impact in the tech landscape?
I think we may see some interesting new hardware advances. I think something that I think we're going to see. I've just worked with some students on a local first project. Local first software, basically everything runs on the client.
Right.
You can sort of think Napster, but in a modern age. Basically, so everything's done with crypto hashes, or you can think blockchain without all the bad people, whichever way you want to. But basically, so you can, because my phone has a terabyte of RAM on it,
Right.
and a
Right.
Snapdragon, that's
Yeah.
fast enough to run Windows, right?
Yeah.
So that's a lot of slow software to run pretty fast, right?
Right.
And so I think there's really an opportunity, and I think with the ability to downsize LLMs or machine learning in general,
Right.
there's a real opportunity to basically build very intelligent devices where your data is your own,
Right.
and where you can do a lot of the things you want to do locally,
Right.
and not be feeding the bandwidth sharks and the cloud vendors. I mean, it's horrific what things cost doing cloud computing. Now, some people, when they were in the happy land of infinite VC money, didn't care. But there's a lot of companies now that are really trying to figure out, oh, I better delete half those services. I can't afford to have Datadog plus XYZ because they're sucking up 50% of my cloud bill.
Right. Right. No, I'm so glad you're talking about it. Yeah, because the cloud cost just creeps in. What starts as the $2,000, $5,000, $10,000 per month quickly creeps into 80, 100K a month cost for these cloud services. No joke.
And I know friends that are working are reducing, double digit millions,
Right.
per year, right, on cloud
Right.
bill. But because you have, and so I think one of the advantages of when I was young, machines were small.
Yeah.
So, I mean, it's 32K, 64K bytes. You ran the compilers, everything in it, right? I mean,
Right.
ran the network operating system. I mean,
Right.
you can't do anything today in that. But we've got very small, cheap devices now. These systems on chip. So I think there's a real opportunity for a revolution there. And I think making these devices smaller and separately, so you don't run everything. I mean, the nice thing about having enough memory is you can have isolated processes. So you can get more to a model, which I'll attribute to Erlang. Others may call it microservices or whatever, but I think Erlang pioneered the model in the telco area. So these are very safe multi-process applications and maybe multi-CPU applications. And I think you can build a lot of interesting stuff there. And you can do a lot of the processing that people are, sending tons of horrible JSON files, the most inefficient way to do anything, off to some other tool to get analyzed and sent back, and they produce it in some other format. I mean, it's just disgusting the amount of money and time that's wasted. But if you're not short in money and time, or you don't have a competitor that's smart enough to do it differently, but I think some people are going to figure out how to do this, and they're going to really punch a hole in what you can do, and whether you need a cloud or a supercomputer, for doing a lot of these operations. And I think that's an exciting area to look at. I think we're going to do something with, we're going to see some biological stuff as well. Yeah, I mean, but that's probably 10 years or so out. But I think that's going to be very, very interesting. And I think
speaking of biological, do you mean like neural link and stuff like that, chip in the brain, things like that?
I think you're going to see that. Plus, you're going to, there's a whole lot of interesting stuff that they've come along with, and lots of things where basically, if you can have something very simple that, and a lot of them, right, then they can do, emergent computation of a sort on their own. And I think there's just a lot of applications there.
Right.
I think the real question is, what are we going to do with the mess of software we have, and how are we going to get forward? I mean, short-term ChatGPT is going to make more software.
Yeah.
I mean, it's just going to, generation, I've never been a fan of software generation, because reading the code is always worse than writing it yourself.
That's right. Writing new code is always faster than maintaining an existing code.
So I think, maybe we'll find some way to do that. I'm going to see Michael Feathers and I are both talking at Go to Chicago next week. So I've got Michael's first chapters of his book on AI, and he's talking about applying AI to legacy. So that'll be interesting. But I think we're going to see some pretty interesting tools to help people. But I think one of the things we really need to upscale some of the software engineering things that people don't know. Because one of the reasons we get into scaling problems and big messes is because we start with something simple. We've got a nice Ruby on Rails site that we put up really quickly. It's running perfectly, but now we've gone to millions of users, and so we're in a heaps of pain. So you make quick decisions with the best information you have. I'm not faulting anyone, but you get yourself in a hole. So, what are the design principles for scaling and things like that? What are the sort of key software engineering principles to keep in mind when you're there, so you're sort of ready for when that next thing hits you?
Right. How do you balance this one, Dave, in terms of like technical debt and innovation? Because like companies are just like you mentioned, there's like ton of code, millions of lines of code, and sometimes, of course, the enterprise do have the problem of like technical debt, and they feel guilty about it, but at the same time, they have to continuously innovate as well.
Yeah, well, fortunately, we don't have time to talk about technical debt, but that's a word that's been made up by a lot of people who want to sell a lot of stuff.
Right.
It's a commercial. It's a commercial term. Definition, and he was talking about same with refactoring. When Ward can't use the term, they're talking about what you do over the 3 days when you made a bit of a mess with some code and then you fix it. That's what technical debt and refactoring about, which is how small talkers are supposed to work. It's not about working for 3 months on something and then begging for technical debt cards because you made a mess. And it's not about the fact that it's not about okay, well, we've got this old COBOL PL1, whatever it is, program. I would argue if it's making money for you, I'm not sure that your technical debt matters because the technical profit probably exceeds. That's the reason you're worried about it. That it's actually maybe you should call it a heritage software, right? It's making good money for you. It needs to be modernized. So my approach to modernization, actually, I'm talking on Monday, is basically innovate at a point that matters to the company. So look at the value chain for the business, for the software stream. Pick the parts that are where you can make a big difference, and insert new technology or practices there, but don't. Rewrite is a path to failure, or certainly spending a lot of money. So rewrites are just not a good idea. That's well documented, but it's like adding people to a project. People still, well, I'm sorry, we really have to rewrite it. You're lying. You just want to rewrite it. So the real thing to do is say, look, okay, I can insert a new technology. Could be hardware. That's the easiest thing. In this point, and I can really speed things up, or I can change the cost equation for this. So that's why I call it innovation in a legacy. And I've been doing last year or two, I've been doing some talks on that. But basically it's small team, 1 or 2 points in the software, and you can make a huge difference, give the software many more years of life without rewriting it. Now, I understand, IBM and others are going to take COBOL and convert it to Java with an LLM. I wish everyone luck.
No, on the topic, I had a quote that I had taken and kept it. This is, I think I took it from Megan Kelly. Her mom used to say something in term, nothing to do with software, but it kind of aligns in terms of like how the time is ineffectively used, right? So she used to say, your lack of preparation doesn't make it an emergency for me to handle it today. So
well said, yes.
So I loved it. So I just took and kept it. Dave, that said, I want to take you through some memory lanes, a 20-year before, and then another one 40 years before. Maybe I'm going to show you like quick clips of a video, and then maybe you can respond to it. I'll ask a question after the video is played.
Okay.
It's gonna pop up in your screen, I suppose. Let's try it. I'm gonna try playing it. Do you see it?
Yes. I see the Eclipse Museum.
Got it. Yeah. So what is your first thought when you see the Eclipse logo? That is first question number one. And like, what provoked you to create an IDE, and what were your thoughts when you launched Eclipse IDE?
So I was working on strategy, and at the time when Sun came out with Java, it's a longer story than I can tell you probably in the time we have, but it became very, very clear for a lot of languages, because the Java strategy was not everything had to be in Java. So that meant if you had a product in any other language, including C or C++, it couldn't get the Java copy cup. So by definition, it was a legacy product, which is an intentional thing by Sun. Good move, you would argue. So the IBM was in a really difficult position, and so we'd done some research in Ottawa and in France, in a lab in France, running multiple languages on the IBM JVM, which is known as K8 at that time. And so we were able to run both Smalltalk and Java, and Rex the Wonder Dog, and all these other BASIC and things like that on this one language. On this one, we couldn't run C or systems language. We could just run application languages. And so we basically, IBM decided after they did the acquisition that we would be the lab to build Visual Age for Java. But even with Visual Age for Java, Sun wouldn't give us the coffee cup because it wasn't written in Java. There was a whole lot of quite nasty tricks, which I won't bore you with.
That's
so IBM was really in a hard place, and so I basically came up with this strategy, which at the time was, I wrote the paper. It was called Blue Planets, and the idea was to build a complete open source world where every part of the Eclipse would be, a separate .org.
Right.
It didn't happen that way, but I won't bother you with why that either. So basically, and this would provide an environment that IBM could offer to people like Rational and so on, which allowed IBM basically to take over Rational Rose eventually. Rational. Eventually, because they already moved into. So we came up with a strategy of basically leveraging our relationship with the Smalltalk with all the universities, and Smalltalk suppliers said, look, what we're going to do is build an open source environment called Eclipse. And it actually was a runtime for something called the UVM or Sunburn, which was a universal virtual machine to run multiple languages. But unfortunately, for accidents of history and people who I won't name because I will get too angry, IBM decided not to build the runtime. So we just built the IDE. And unfortunately, that also resulted in Eclipse not being as multi-language as we would have liked it. But that's what that's how it came about. And first version we actually shipped for an embedded. I don't think anyone knew it was Eclipse, and then that one you showed was the one that's usually by the time you release the third version, it sort of works pretty well. The first version is usually too big and too slow, and the second versions, and then third version usually works. I mean, that's just it just takes 3 times to build decent software in my experience. So
that's right. Speaking of like IDEs, I mean, like Visual Studio, which like I know, like was it primarily or heavily inspired by Eclipse? You would think.
Visual Studio Code or Visual Studio?
Visual Studio, Microsoft Visual Studio, was it heavily inspired by
Visual
the Eclipse?
Studio? The original Visual Studio existed before Eclipse.
Oh, it did? Okay.
Yeah, not Visual Studio Code, though.
Not VS Code, no. The Visual Studio, the original one.
VS Code was done by Eric Gaumann, the same team that did Eclipse.
There you go.
In Switzerland. Except this time he learned that you use scripting. We tried to convince him to use scripting, but he put all these APIs in. But when he did Visual Studio Code, he did everything with scripting, which so in the end,
got it. Now, what was like, because like something I always had this question in terms of like for Microsoft, for Java, it has always been, the world of Java has always been open source. Like you download the Java virtual machine and keep going with it. But before
open source in what sense? You need to read the Sun license.
Got it. Okay. So, of course, for enterprise licensing and like for commercial licensing, there's a different way to model it, I'm sure. But my question around Microsoft was, it took a long time for them to actually even embrace open source.
Sure. Because it wasn't successful. I mean, if you've got a successful proprietary product, the time to move to open source is when you can see. I mean, basically, that's what we did. We could see that a proprietary product wasn't going to take us there in the marketplace. We could tip the market by going open source with Eclipse, supporting all sorts of university extensions and so on, and change the market. So there was a market advantage to go, you basically, but, if you're a Sun, you're not going to open source because you have a leverage. You're licensing it to people. So it's all about commercial advantage. Eventually, Microsoft was in the position where it wasn't advantageous for them to not be open source. So now they're aggressively moving source. I mean, the Roswell, whatever the latest C# is all open source, and it's a brilliant project.
Right, right.
as
Do
is
you think the
Visual Studio Code, right? Both of them are.
God? Do you think the movement of like open source has clearly like helped the tech community, when it comes to AI, do you think open source is still the right way to move forward with?
I think open source is great, but the problem is, we really need a world of pay by means, because the
Mm,
problem with open source is that you know the money only goes to the top of the tree. So the problem is people are building runtimes like VMs and so on.
right.
They get very little support, very little money for the hard work they do. Right. Yet you
Yeah.
get some goofy web framework that's on top, which people are charging $1 million for. Right. But the
Right.
value that framework wouldn't work without all the hard work that's underneath. So
Right.
down in the engineering room, things really suck the benefits from open source.
Right.
Um, I think open source is great, but I really think you should be, and you get all these banks. Basically, I don't want to pick on banks. Sure, I pick on banks anyway. They have all this money, and what they
Yeah.
do instead of actually buying a product,
Yeah.
basically they'll hire 20 outrageously priced consultants to
Right.
write them, take the open source and modify the hell out of it, make it something that the bank has no technical debt with, because
Right.
they modified the open source.
Right.
So that's what I mean. I think people should pay by means. If you're getting the value out of this and you can afford it, you should be able. I mean, it's a utopian view. I understand that,
Right.
but in the
Right.
end, the pay by use license, I think, makes sense. The same thing with all the cloud vendors, right? Who basically just take all this open source and
Yeah.
put it on their cloud and then sell it to people.
Yeah.
I think it's reasonable for the
Right.
open source. I mean, we don't have to have a big number. We can start with a small percentage, but to get none of the cake,
Yeah.
right,
Yeah.
and be providing the software is just unreasonable.
Right. Right.
So
In terms of
it's a good idea, and a lot of companies should get the source, but not be able to
right.
modify it.
Right. Right.
So, because I think open source is very important for understanding, debugging, and things like that. But there's lots of people who
Right.
should never modify the open source,
Right.
because that's
Got
you
it.
find a lot of companies. Oh, this is great. We'll get this open source. They pull it all in. Then they say,
They
well,
fork
what we need
it.
to do is we need to fix it, fork it, and
Right.
it's
Yeah.
really well forked after that, right?
Yeah. That's right. I mean, like when it comes to API calls and things like that, there's always okay. You can call like 50,000 times or 5 million calls and things like that. And but when today's speaking of open source and AI, obviously there and GitHub is obviously there's a ton of open source code, like millions and millions of codes out there, and like what stops AI from like machine learning all of it and basically spitting it out when users ask for different pieces of like requests
That's
on
what it's.
ChatGPT or
But that's what
otherwise?
Copilot's doing.
Right? Exactly. Yeah. Exactly.
Yeah, I mean, yeah. So, well, there's the issue of copyright. Do
Right.
I should there be rights there? I think that's definitely it. I mean, I don't think that was what anybody put their source wasn't thinking of that, but I think you'll see new licenses reflect that for
Yeah.
people that are offering something like GitHub. I certainly wouldn't, particularly if you were doing something fairly unique. That would be very
Right.
dangerous. If you were the first person doing
Right.
Rust or something like that, and you were building
Right.
something significant in Rust, and you were the first one, and you solved, bumped your head on all of, early adopter problems.
Right.
You really want everyone to learn how to write good Rust code, but your benefit, right? I mean, without any benefit to you, maybe you
Right.
do, maybe you're altruistic, but I think the other issue is that um, this LLMs. I'm not an AI downer, but the potential of security violations, threat vector attacks, and so on generated by AI is very serious. Um,
Right.
and I mean, Facebook, opened the door basically because they had no choice.
Right.
They wanted to stay in the game, so they used the same flip trick as Visual
Right.
Studio as Microsoft. Basically, will go open source.
Right.
But what that does now is basically put that technology out there for a lot of very evil criminals and
Right.
government actors, and so I have to say I was pretty nervous when that happened. In some sense, not that I have great faith in uh, OpenAI or Google protecting the world, but
Right.
in some sense, the fact when it was contained, um, I guess I would have just I mean I think it was inevitable that it was going to happen, but I would have liked it to be delayed a couple more years.
Right.
But it may work out to be the best anyway, right? I mean, it may
Yeah.
be, but it's going to make it hard to protect against lots of things. I mean, it's
That's
you
yeah.
know,
That's true, and I'm sure. Like I think the recent development is Apple trying to put OpenAI into an iPhone, where pretty much every text message and everything is basically like machine learned and like uh, picked up from the phone, right?
right.
Yeah, yeah.
So
Not sure if that is the right direction for
yeah,
humanity, but
so I think that's one of the arguments for this local first stuff, right?
yeah,
Basically, if it's your device and you control what's running on it,
yeah,
then and you work peer to peer with other people, and it's all cryptographically protected and so on.
right.
Um, you're going to now. Unfortunately, they've just in the publication of how many crooks and bad guys are use Telegram.
Yeah,
So
that's true. Right,
it's basically we have this human problem, right? Anything that can be used for good can be used for evil. So
that's true.
the
That's true.
the danger is the more powerful the evil, the more risk associated with it.
100%. 100%.
Anyway, I don't want to be Debbie Downer, but uh, uh, and I think the other problem is the threats, supply chain threats to small modifications to
Right.
open source code. Those are really scary, and the fact that a lot of open source projects aren't financially stable.
Mm,
There aren't enough developers because they're not getting compensated.
right. Right.
Right. So there is a compensation problem with the open source model. I think it was a very naive model to begin with. I'm not a GPL fan either, but there needs to be there should be some model where basically that says, okay, I'm using this, it's worth something
Right.
to me.
Let me ask you a different question, the complete opposite of open source, which is the closed source, right? I mean, like BlackBerry from Waterloo, Ontario, right? I mean, had a great phone, had sold a
They're right
lot
down
of
the road
devices.
here. Yeah. Yeah.
Yeah, and they had a very successful launch of their device at the time, and they had like so many people would only use BlackBerry for their emails and Outlook and whatnot. You know what I know. So, why do you think that model failed? Do you think it is because of not they did not transition soon enough to an iPhone type of a
Yeah.
device? Yeah,
They didn't move fast enough.
right,
they didn't see the train coming,
right,
and they didn't move fast enough. I think I know a few people trying to sell them embedded Java and other things, but they were busy doing their own thing, right? So, but I mean,
right.
that, as I said, one of the things is that when you're the gorilla, you know, look down and say, "Oh, that little ant's not going to bother me," right?
Right, right.
So
That's right.
I think a phrase that many people have used, but I love is "only the paranoid survive." Right? You have to
Yeah,
believe that every competitor is serious.
that's right. That's
You
right.
should never insult your competitor. Basically, you should always respect your competitor.
That's
And
right.
yeah,
Yeah, I was
I think
referencing
that's one
that
of
book from Andrew Groove, The Only Paranoid
yeah,
Survive. Yeah,
yes, yeah. So I think that's one of the things that worked well in a lot of the programming language areas. Like a lot of people work on virtual machines through the sort of OOPSLA and eCoop and follow-on community functional programming. Those conferences, there's a lot of sharing uh, between people in different companies because they're all concerned about making their products better. And
right,
in some sense, that basically the only time you get to improve your VM is if your competitor announces something. So
right.
you're always excited if they're doing better because then you've got a bar to raise. So I think
Yeah,
it creates a very healthy ecosystem
right.
there.
That's right. That's right. I want to get your thoughts on the next video. I'm going to take you to memory lane probably by 45 years. How are we doing by time? I still have another 20, 30 minutes worth of
Whatever.
questions or even.
I don't have a time, so it's all right.
Okay, cool. Let's roll. Let's do it. So this is taking you to the date of like August 12th, 1981. So let me play the video for you so that.
The very first computers seemed as big as houses and so mysterious that for most of us, the computer was behind a closed door. But IBM was thinking how to make the computer more useful. And as one good idea led to another, it began getting smaller, faster, less expensive, and easier to use. Today, a new IBM computer has reached a personal scale. A person can afford it. A person can put it anywhere. Office, home, or school. And a person can learn to use it with ease. IBM made its personal computer to help a person be more productive, to help a person be more creative. And those are good reasons for a person to feel good. The IBM personal computer, now at selected stores across the country.
So that was that. I love the video. I just took it from the initial 1981 launch video.
It's a great video.
What was your thought?
And it was definitely a breakthrough. Although I mean, Apple already pioneered it, but it was definitely a break, and Atari and a few others. But it was definitely a breakthrough, and it was only possible because IBM did it outside of IBM. Right. They did this is the old innovator's dilemma problem, basically. Very hard to do innovation inside of an existing organization because everyone thinks a certain way. This is what made us successful. We're gonna erode our own market, confuse people, all those sorts of things. So it was a very brave move on the part of IBM and the brilliant individuals that did it.
So you lived through that time, Dave. So what was your thought process like on like August 12th, 1981, when you saw this ad? I'm sure you would have seen it on television or otherwise. What was going on in your head like 45 years ago?
Well, I had a friend who was building, so not sure when CP/AIM came out, but it came out before MS-DOS. So in the 80s, early 80s, I was using, as we say in Canada, Z80 CP/M microcomputers. So we were already producing, worked with a hardware company that produced microcomputers for process control. And so it didn't surprise me at all. I think it just legitimized this as a regular market, as a huge market from a kind of niche market where people were building them as kind of instruments. Right, this is part of your factory or whatever it is, or part of your. So I think it legitimized it, but I don't think it wasn't a surprise. I mean, there've been rumors for some time that some major vendor would probably do it, and Apple was really taking off. So, I mean, I remember I gave a talk in 1979 or something on auditing databases, and at a international conference was in Toronto of computer auditors, very exciting people to be with. You can, and basically the night before was a party, and I had my talk in the morning. I said, well, I don't know what these people are going to be like because, auditors weren't super technical in those days, and and in the bar and everything, everybody was talking about VisiCalc, and and Lotus, right? And they
Lotus Notes,
no, the 1, 2, 3 Lotus, the spreadsheet, and so VisiCalc with, and so I thought, well, I need something to open my talk with because this is going to be dead boring, talking to all these people in the morning or afternoon. So I said, just before I started, I just wondered how you dealt with the fact when you're auditing that there's a bug in VisiCalc.
Right.
and the entire room just went completely silent.
Right.
Because they just trusted the spreadsheets just worked.
Right. They never thought it
Anyway,
could have a bug. Yeah.
I went on and gave a very boring talk after that, but people remembered me because they said, "You really got us this morning."
Right. In your in your trend, in your history of like your career and things like that, what are some of the like most absurd trends or buzzwords that you're most annoyed with?
Most
Because
annoyed.
there have been lots, right? I'm sure.
Well, certainly SOA was one of them.
Service oriented architecture.
The
Yeah.
SOA was a architecture. Basically, that was some slides that got put together by Sun and IBM and Microsoft, so they could basically fight the people like Commerce One and Vitria and so on, the commerce integration vendors. So they basically poofed up this fake standard
Right.
with all this stuff around it. So it was probably the world's best architecture.
Right.
So I hate things that are just phony. It bothers me that people use the word AI, but I'm almost over it because it's really mostly machine learning.
Yeah.
So,
That's right.
I think after a while you just it's just like one of those. It's like Agile. It just doesn't irritate you anymore. You just know they don't know what they're talking about, really. So just be nice to them. Don't get in a fight, right?
Yeah, that's right. In your speaking engagements, I'm sure, like I did mention it, like you try to bring humor like none other, and I love it. And like I've already mentioned it, like how important do you think humor is and important to business and technology, and like does it serve a larger purpose than actually entertaining audience?
Oh yeah, I mean, I think it changes how you feel about things. It keeps a
Right.
smile on your face. And it certainly helps you solve problems. I mean, basically, I can remember at various companies, including OTI, we would have these meetings, and we would have some hard problems. We'd go around the
Right.
room, and the clock would tick. Someone would order some food. We'd still be going around the room, and everybody, well, we just can't do this. This just can't work, right? They were called I'll be polite, the "we're screwed" meetings, and basically, and eventually, someone would basically just throw up their hands and say, "We're screwed," and
Right.
eventually everybody would nod around the room. Maybe someone might hold out for a few more conversations, but then the final
Right.
person would say, "We're screwed," at which point
Right.
someone would get some scotch, at which point then we'd decide to delete something, right?
Right.
Which is the only way to get anything done. The only hard decisions in business and technology are what are you not going to do, right?
Right.
If you can figure out what you're not going to do, you're in great shape, right?
Yeah. That's right.
But
I
I
was
think,
reading this
and
up. Yeah.
I think the fact that we could do this and we could just burst out laughing, even
Yeah.
though we're in this incredible, pressure kettle of the delivery that we maybe couldn't make or whatever it is. I think it's just, well, look, all you can do is the best you can do,
Yeah.
and
Yeah.
and often if you basically can laugh at it or maybe curse it, as long as it's it, not the person, you can you get fresh ideas,
Right.
or you just come to deal with the fact that you can only get 5 pounds in a 5 pound box, right? That's
Yeah.
um, and you get to move on. So I think it gives you the
Mhm.
ability to to have some perspective.
Right.
Um, and I think the thing that bothers me about technology is when people hammer you with it, and the fact that you
Mm.
don't understand other technology. So the ignorance of previous technologies. Like, I always like someone shows me a new technology. I always like to know what's it most like that we've
Right.
seen before, and how is it different. So basically, if I get a tech paper, that's all I really want in the front. My language is like Zot,
Right.
but it does these things differently.
Right.
And if they can put that like in one paragraph on the paper, that's
Yeah.
I don't need to read the paper, right? Basically.
That's right.
That's the problem. People, things are so complicated, right? But what's the essential? What's new here, and why is it good? And
Yeah.
what did you take out, and why is it good? And then what are the new things you've added? I mean, it's
Absolutely.
and I think that's one of the benefits of having a good foundation of understanding computation. Is very easy to see a new technology come out and just go, okay, it's like this, but not like that. So you can take it apart very quickly. I think people who don't have the gift of understanding that have a lot of work to do to learn, to go learn Rust, because for them it's sort of a whole new experience, right?
Right. Yeah.
Versus, basically you say Rust, okay, yeah, watch out for the ownership types, right? I mean, that's the, so there are other things that you can go into, but basically, there's 4 or 5 things that really make Rust unique and useful relative to other languages, right?
Right. I mean, speaking of basically like paraphrasing it or like summarizing it, I think I was talking to someone about an idea in terms of like we often get into a situation of like agreeing to terms and conditions without ever reading it, and there are like hundreds of lines of actually pages that we actually don't read it, and if there was a way like with AI, I'm sure like we can summarize it into like a small chunk. Here are the 2 lines. This is what the term says. Similarly, same thing can be done for source code as well, for libraries and for specification documents and whatnot, right? Here's what it's about. This is the 2-liner. This is all it, right? You don't have to read 200 pages of worth of a document to basically understand what it is.
No, I think that's definitely a good use. Remember, the reason they're that big is because the lawyers don't want you to understand them.
That's right. The underwriters and of course.
So so that they'll have to come up with other terms or something. And
Yeah.
they have to use language that's after the date the LLM read the terminology. Right?
Yeah. Speaking of like in terms of like the gaps in the industry, like what do you still see as the biggest gap in the tech industry, and what are those problems that are still are not addressed yet?
Oh boy, that's a big one.
Because everyone are under the impression that okay, we are making progress. Yes, we are making progress, but I'm sure still there are like unaddressed problems that are like carry forwarded into a future setting that are going to be a bigger problems at one point, right?
So I think one big problem is the fact that the business and the devs can't talk to each other, and that's often comes down to neither of them really understanding the domain,
right,
and the domain vocabulary. So I think that just creates a problem where you do things like write stupid cucumber tests, which just burns out the BA,
right,
and you write all this fragile code that's going to break,
right,
and so when you could just take a spreadsheet and run it, and you don't even
right.
need, you have to develop a spreadsheet interpreter once, but instead of, so I think it's just a lot of waste. Way too many people on a project is still there. Not understanding the domain is still there. Not understanding the platform or the thing that you're working on. I think a lot of people have no sense of, they don't really have any idea whether it's slow or fast or big or small.
Right.
That they should be getting sort of a fictitious bill or something like that, right? Every time they build or run something, they should have some idea. I mean, in principle, they should run performance acceptance tests
Right.
every time, but lots of people don't even have decent acceptance tests, right?
Right.
So I think having people with experience. So one of the things that many companies have done, we've worked on it with a few, is having principal engineers or distinguished engineers, having a technical ladder so your senior technical people can stay technical.
Right.
So there is this breadth of experience. Someone who's seen the movie before and said, "No, I've seen this movie and it has a really bad ending, so I recommend we stop now." So there's time to walk the floor and talk to people, and I mean, you learn
Yeah.
a lot talking from your first and second year co-op student,
Right.
and hopefully they learn something from you too. So I think having a kind of depth and variety of experience. I mean, if you have a team with a lot of different backgrounds, it really helps. If they've seen different applications, they can say, well, look, here's the way we looked at it in this industry. And people
Right.
go, oh, wow, that's a really clever idea. None of us have ever
Yeah.
worked in that industry, but they do things
Right.
very different. So
Right.
I think that just comes back, I guess, to having the requisite variety and experience in your people. Um,
Got it.
I think framework should be burned.
Hmm.
Basically, I mean, I think someone could make a good business producing really good components instead of lousy frameworks. It's a
Hmm.
big
Right.
job, but basically, people are dying in frameworks. There's a new framework every
Right.
month.
Right.
Now, how many ways are you going to I mean, I don't know how many new uh, client-side JavaScript frameworks I've seen, but
Right.
and so the problem is you're introducing all this churn and forcing all this rewrite and all this expense and all this maintenance problem and training. So I really
Right.
think um, we introduce new technology far too quickly, and we introduce it before it's reached a certain level of maturity. So I think we want to be a lot more cautious about bringing new technology in. I mean, one of the classic problems we have, for instance, innovation and legacy. One of the classic things is, okay, we're going to
Right.
use this new platform and new language.
Right.
Um, and the answer is you get a couple of bright people who really love that new platform, that language, and they do a great prototype, a great proof of concept.
Right.
And everybody says, oh, that's great. It's proven. So now we go ahead, but they don't do a proof of scale.
Yeah.
So you find out, okay, if it's a new language, I don't care, if it's in its first version, it's not going to be fast
Right.
and it's
Yeah.
not going to be small, right? Basically. So, but people bet the farm
Yeah.
without ever running anything at scale and say, what's it like when you run 1 trillion records through it? Well, we
Right.
don't know. It's never finished, right?
Right. 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 In societal context, they say the free markets decide what wins and what doesn't win. Similarly, in software development teams context, if there are like 30 or 50 people, if you have to solve a problem, obviously probably 20 or 30 people could attempt at it, and the best ideas could actually win. And then that, I mean, whether it can be stress tested, can it be scaled for a larger user group, things like that. I used to think like, why not companies do that? In the learnings that we have from the society, bring it back to the smaller teams.
Well, I think good companies do.
Right. Okay.
The problem is lots of people are desperate to get features because, software is eating the world, which is a phrase I hate.
Yeah.
That basically these companies that should know better are dumping tons of money trying to make themselves digital,
Right.
and they're failing, right? But they should figure out what's their core business, what is it really important to do digital. Maybe they do need
Right.
a mobile app that's kick-ass, but
Right.
then get a really crack mobile apps team or a contractor and build that.
Right.
Again, it's the problem is this systemic change
Right.
to adopt cloud or change technology or digitize is really doesn't make any sense. You know,
Right.
you need to change something that's significant to your business,
Right.
and that's usually not everywhere.
Yeah.
Right? I mean, it's like you're going to renovate your house. Well, do you have to knock your house down and rebuild it to get a better improvement? Maybe you could do the kitchen, right? Yeah.
Right. 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 Uh, what do you make of the? I mean, speaking of the software eating the world, of course, it's not the best term. What do you make of this term? Data is the new oil. Uh,
Hey, if you're in the business of selling data tools, and I think it's a great idea. You just need an engine to put it in.
right.
And the problem is most people. Well, you actually need a person who knows what to do with oil.
Right. Right.
And that's the
Yeah.
problem. we don't know. We know how to refine oil. We've been on it for a long, and we know the purpose that it's for, because
Of
it's
course we
very
do.
single purpose. But data's not like that. So like all good buzzwords, it's a great, great pitch if you're in the data science, right?
Right.
But the reality is most people don't have a clue what to do with data.
Right.
Most computer scientists don't know how to write a decent query.
Mm.
How many of your programmers really like to program in SQL?
I know, right? That's right. Yeah.
But the future of the world, the future of programming, I believe, is in query. I
Mm.
believe the most important, and prompting is the kind of the beginning of that, right?
Right. Yeah.
I mean,
I remember.
so I think if you can structure, whole applications can be done as a query,
Right.
and I think and that saves you a lot of programming, and you can change it,
Yeah.
right? Because it's just a query.
Yeah.
Like
Yeah.
why do you have 500 REST calls, each of which gets different attributes out of some field, right?
Right.
Why don't you just have a
Yeah.
select
Yeah.
and get whatever you want, right? And just change the
Yeah.
select. Why do you need more than one API?
Yeah. Yeah.
You need to do this. You need to do this security for the select. So I just want to be clear. I'm not
Right. Right.
foolishly
Right.
talking about sending a naked,
Yeah. Of course.
SQL request. But assuming you do the authentication properly,
Yeah.
why do you have to have all these APIs? And
That's
then you got
right.
to put GraphQL. It should just be like SQL. Just talk to it. Just
Yeah.
design a schema and query it.
Yeah. Yeah. Why not? Yeah, I remember my first ever corporate job I ever took. The deciding thing was writing an SQL query to back up a database. How would you back up a SQL database? That was the question. I still remember that question. So yeah, I love SQL. I've written a lot of queries. I love that.
I just think it's the way things are going. So it's
Yeah,
a um,
absolutely. Taking your focus into a different topic in terms of, we recently spoke about, like, in terms of like the challenges bringing the teams together, the business teams and the technical teams together. There's a lot of like disconnect, and they don't talk the same language from a domain point of view and things like that. We have definitely like ventured into event modeling, and was so glad to be there in Vancouver to meet you and things like that. So, what are thoughts on like event modeling and basically trying it seems to be an attempt at bringing teams together and have a common model for everyone, for the business team and the technical team, and give ownership to people. What are your thoughts on event modeling?
I think event modeling, and particularly Adam's team, have done a really good
Right,
job.
right,
I mean, again, event modeling isn't a hammer for every nail, but certainly for a lot of people that are working classic, what I would call IT applications,
right,
basically, uh, uh, I think it's a really, really good approach that they have. Um, in the old days, we used to take people when they joined a company, and you would go and work in you would spend a week or two in the different divisions in the company. So you go to manufacturing, you go to accounting or finance or whatever, you go to purchasing, and you meet people there, right? And
right,
you pick up the language. Maybe
right,
not for some places that you would spend the first 3 to 6 months actually out in the company, just learning what the company did. And at
right.
Amazon, if you're a senior manager, you have to drive a fork truck every year in the
Mm,
warehouse. Right?
right,
So you have some sense for what it's like to work and
right.
do the job. And later on, when you have to do something like buy something, which if you're
Mm,
a technical developer and you want to figure out how to buy something in a big corporation, this is like, what
mm,
the hell do I do? You call
right,
up Mary, who's in purchasing, and say, help. And she says, oh, yeah, I remember when you were with us, joined us, come on over. They show you how to do these things, but you
right,
pick up the domain vocabulary. I think this is the problem. We basically, because we have instantly reusable computer scientists, we have a whole
right.
lot of people you can't talk to.
Yeah.
I worked with a company in Ireland. They hired
Mm,
400 non-computer scientists every year. Maybe they'd taken one course in computing, bright,
Right.
talented people, and they trained them in an exotic functional language
Right.
and in capital markets, options, stocks, swaps.
Right.
And they were consumed immediately because all the people in capital markets just loved these people because they didn't have to explain what net present value was,
Hmm.
all this stuff. These people came in and knew the domain, so they could
Right.
be leveraged right away. And I
Right.
think that's basically, I would basically just have a domain training for the teams that are coming in, and basically said any developer comes in here goes to domain training, right? Whoever you do it, they can be part of a team where they have someone in the team doing it. They can go off work with the traders or whatever, however you want to do it. Send them to a special school.
Right.
Fast track. I mean, Arthur Anderson used to, and R.L. Crane used to train people in given domains so they would
Right.
know how to talk to people in the hospital. What was important in terms of the vocabulary, and so I think
Right.
that just breaks down all these barriers,
Right.
right? Versus trying to explain this minutia to some agile developer, because they don't know what net present value is. I mean, come on.
Right.
So companies just don't make the investment.
Right.
And now the other problem, of course, is that lots of the business people don't know either
Right.
because they also haven't taken the orientation. So they just
Hmm.
move from Department Y
Yeah, we
to
assume they know,
Department
but
Z, and they know nothing about what Z does at all. So
right.
they're just as lost, as the IT person.
Right.
So, this whole issue that you somehow assume that you know things,
Right.
that the people know things, it's crazy.
Yeah.
And so, the good companies invest time in people to make sure they know what the hell a company does and why,
Right.
because that also helps them make bigger decisions. If
Right.
I have a system and I've got downtime or something like that, what's the most important thing to the business? It's this,
Right.
right? So you have a context to work in. So I think that's, you know, it's not about domain-driven development. It's about knowing what the domain is about.
Yeah. Yeah. And when people accept like what they know and what they don't know, I think there is a lot of like strength to it, and there's also a lot of wisdom to it when you're able to have the courage to basically accept to things that you don't know. And speak truth to the facts, right? This is what I know and this is what I don't know. Able to clearly distinguish. So when you don't know, you can actually always reach out to that expert who knows about stuff and then talk to them instead.
Yeah, only trust the people who say they don't know, right?
Right. I
That's my
personally,
my my view is
right,
basically beware the humble man, right?
right,
Because they don't have to tell you, right?
right.
The other people have to tell you what they know.
Personally, Dave, on a personal note, I've learned to accept that I will not know everything, and when I say I don't know, it is actually giving me at least an opportunity to go out and learn and seek what it is. Right,
Absolutely. I
right,
mean, and tell me some people who do. I mean, how many people go into a new situation and know? I mean,
right,
I mean, some people have a good sense of people, so I can kind of sense that things are not going well in this meeting, and I can sense
right,
the human thing, but they're talking about such and such a parachute and how I mean, what do
right,
I
right.
know, right?
Of course. Uh, Speaking of like technology and the evolution of like the financial landscape, especially, everyone saw what happened in 2008 and the financial meltdown in Wall Street and things like that. And what seemed to the antidote for that problem at the time seemed to have like the decentralized Bitcoin, which is of course it's anonymous and things like that. Now they are trying to do KYC and things like that through exchanges and whatnot. What are your thoughts, quick thoughts on Bitcoin?
I think Bitcoin is really interesting. Uh, it's very unique technology. I like it because it's limited,
Right,
right? So unlike the other, whatever uh, Bark coin or whatever it is that you want, it's you know they're really. So I think it's interesting. However, it seems to me it relies on psychology to
Right.
sustain its value, right? So, um, I mean, I don't think it would. I think if one has the money, it makes sense to have some small percentage of it in
Right.
Bitcoin or maybe some other, uh, equally safe uh, crypto. Um, but I mean, the problems of crypto are basically bad software and bad
Right.
people.
Right.
So, we've had the crooks and the bugs, and that's really what's hurt it. The other thing is that Bitcoin seems to track the stock market a lot more than it does
Mm.
the price of gold or things like that. So it's still early days, but I certainly think that, if I felt like, you know, um, I was going to be around for a long time, a lot longer than my lifespan, maybe I would put more into Bitcoin. So I can understand why younger people, they see it as but I think it's still early days to really understand it. And, you know, maybe after we've had Bitcoin for 20 years, we'll know
Yeah.
what it is. I mean, 20 years of serious trading of it. I mean, it's been around for a
Right.
good while, probably 20 years. Um, so I think it's interesting, but the issues of trust and efficiency and so on, and it's hard to say in some sense that it's not like a stock, right? I mean, yeah,
Mm.
so you talk about mining, but it's not like gold,
Right.
right?
Right.
Well,
Yeah.
don't use the term mining then. Yeah.
Yeah, yeah, it's not really mining. It's it's actually trying to record a transaction that as
So
simple as
well,
that.
and generating, so it's very interesting. Blockchain is not very efficient for lots of things, so I think that's. I'm glad to see that proof of stake is sort of coming in over proof of work. I think that's proof
Right,
of work's not a great idea to burn up all sorts of power and electricity for
right,
something that's supposed to be really efficient. It's also not. It's also really dominated still by whales.
right,
So and it's also not very well distributed. So some of the sort of theoretical claims are not actually valid
right,
or as valid as one would make. But I think it's very interesting. I think
right. I'd
as
like
I said,
to.
if I was 20 or 30 years younger, I probably would be more adventuresome with it, but I'm not. So.
I'd probably spend another 10 to 15 minutes past the max and then probably wrap and then with the rapid fire question and things like that, another 10, 15 minutes stops. I just want to play this quick video on Bitcoin and then maybe ask you about fractional reserve banking after that. And maybe we'll get into the closing of it. So I'm going to play this video. Is it playing?
What is this archaic system?
Mother's maiden name? Leibowitz?
You're telling me this guy is how things get verified.
That's my job.
I'm just saying, you shouldn't have to buy $10 worth of gum if you just want 79 cents worth of gum. Why do you get charged your money to take your money from your account? And if you're out of money, they charge you for being out of money?
What?
An overseas transfer takes 5 days?
Business days.
Why?
What are they using? A Zeppelin?
I deposited the check Monday.
But Monday was a bank holiday.
Why is this the way it is?
A bank holiday?
This system
What's a bank holiday?
makes no sense.
This makes no sense.
Who designed this system?
Ma'am?
Is this really the best we can do?
Hello?
Don't we deserve better?
Your quick thoughts. I know it's a heavy one, but
we all know that banks suck. right? And then the banking can be made more efficient. And
Right.
maybe if there's enough competition from something like Bitcoin, there will be
Right.
pressure to change them. I believe that's what will, in general, if there's enough competition, things will change, right? Um,
Right.
I mean, I really think that the amount of money that the fees that are charged for credit card transactions and things like that
Right.
are outrageous.
Right.
Uh, um, so, but you know,
I just I was reading in a book in a book, Dave, and one question I had was like not related to Bitcoin in particular, because like let's say we have spent a century and beyond, we have created so many inventions, we have automated a lot of things, we have optimized it, the efficiency of a lot of things have gone better, the rate of production of agriculture and technology has actually increased multifold and across industries, right? So there's a lot of cost savings to companies. Why do you think the cost of living keeps increasing when there's, because one side we have improved the efficiency, but on the other side the cost keeps increasing? Why do you think that that's happening?
oh, I mean, you can just read any of the economists or whatever it is. Basically, um, one of the issues is that the governments have borrowed a significant amount of money um, after COVID. All the people who could started, basically we have to make up for what happened to us during COVID, or
Right.
we have an opportunity that's as good as we had in COVID. And
Right.
so um, businesses just increased their prices, some justified, some not. And
Right.
that's, drives inflation, and inflation drives interest rates, which, hits housing and car loans and things like that, which are, things that really hit people, and food. So,
Right.
um, it's hard to find the chicken from the egg in some sense, but I think most people will point at major government borrowing after 2008 and
Right.
during COVID
Right.
as being the triggers, and
Yeah.
as well as COVID itself.
Yeah. I we moved to Alberta like 2 years ago, and something I remember, like I bought something from Walmart at the time. I particularly remember that like there was a particular equipment I bought. It was $9.99, $10. Exact same equipment I saw like 10 days ago. That was $39.99, $40 in a matter of like I think 4 years. And I clearly couldn't understand like because there is a cost to it, right? Because what used to cost $10, now I have to shell out $40 for it, and there is a pain that society goes through it, right?
Yeah, absolutely. Wages have to go up then accordingly too, and so yeah,
Right.
but it's a complex.
Topic.
It's a complex system, and basically,
Right.
so I mean, you know, after shipping, getting a shipping container after COVID
Right.
was almost impossible. I mean, they went. Um, I live in the Caribbean in the winter, and a shipping container doubled in price, like
Right.
$7,000 to $14,000, and you were on a 3-month wait,
Right.
and you had to prepay $2,000 or $3,000 to guarantee you get the container, or
Right.
else they just say you would just have to go on the wait list.
Got it. Got it.
So so it takes a while for that market to reset, right? So the enough
Right.
boats in the right places and everything like that for and then
Yeah.
the price will start to come down again. So
Got it. Dave, that brings us to the final rapid fire section. These are like fun little questions. Like you don't need detailed answers. Like just quick questions and rapid fire questions. Maybe a short phrase or few words are great. But if you want to elaborate, please feel free. So here's the first one. Like if you weren't in the tech industry, what would you be doing instead? If you weren't in the tech industry at all.
sorry, does that mean if I wasn't an engineer?
If you weren't, yeah, if you weren't in the technical field that you're in currently in the computer science world, what else was your motivation, or what else would you been doing otherwise?
Well, originally I wanted to do medical engineering or toys.
Got
So
it.
I
Okay.
still would vote for those as being two interesting areas to be in.
Okay. Very, very interesting. What is the one thing about you that most people don't know? Uh, just one thing that anyone wouldn't know yet.
I have no idea. No idea. That's a question that you're supposed to ask the LLM. I just saw that the other day. So I'll go and ask. I can go and ask, ChatGPT and Claude to see what they say.
Right. Okay.
I have,
Maybe let me rephrase. Sorry. Go ahead.
no, that's fine.
So maybe I'll rephrase the question. Are you like a coffee person or like a tea person?
Coffee.
Okay, good, good. If you want to have dinner with like a historical figure, who do you think it would be, and why?
Boy, so many.
Okay, you can name a couple.
I and I just lose his name.
You can talk about his achievements or something like that.
Yeah,
We can bring his name afterwards.
very very well known for his Seymour Papert at MIT. His work in education and AI.
Got it. He's a historical figure, or the current.
He's passed away, but basically logo started under him, but a lot of things started under him. So, and he really encouraged different models of learning and working with children and so on. So, key
Got it.
person at the MIT AI lab.
Got it. Got it. What is that one gadget or the tech innovation, something that you cannot live without today? Is it a cell phone or a?
No, I mean, I need some sort of tech device, but I don't really care what it is.
Got it.
Yeah, I mean, it doesn't matter. I can live without a cell phone,
Right.
but
Got
I'd
it.
want to have a tablet or a computer or something.
Got it. What is the last book that you read and that you would recommend to anyone reading?
It's the last one that's hard.
You read multiples.
Yeah, I think since it's a software audience, I'll give them one. I think Dave Farley's book is a great book. His book on software engineering book, which basically comes out like a new book, but actually has all of the established and well-known principles in software engineering, but written in a modern way. So I think that's
Okay.
That's a book I recommend to everyone, particularly younger people in the industry. So I'll go
Got
with
it.
that.
Got it. What would be your like favorite way to unwind after a long day? Is there some practice that you do? Okay, this is how I unwind. Probably a glass of wine or something. Or what is your favorite way to unwind?
I like to walk or I like to swim if I'm somewhere near the water.
Okay.
And I like to bike as well. So those three.
Got it. If you like to instantly master any skill, what would it be?
Be able to read faster.
Ah, yeah, I love that too. Yeah.
Well, sorry, read and understand faster.
Yeah, yeah. That's a good one. Is there a particular phone in your app or anything that you cannot live without, Dave?
Sorry, a particular.
Is there one particular software app or on your phone or on your computer that you cannot live without?
I need to be able to communicate. So,
Got it.
have to. It could be email or it could be messaging or whatever, as long as I can communicate.
Got it. Got it. I think. Okay, here's the last one. What is your? I think this doesn't have to be a short answer, but like, what is the advice that you have? The best advice that you have ever received, and what is the best advice that you want to pass on to anyone listening? Something that you received and something that you want to pass on.
Well, the best sort of career advice that I ever received was to go with your heart. So if you really feel a passion for something, to go with your passion, and not to take all those programs that wanted to say, you could become a good manager. If you don't want to be a good manager, don't.
Right.
Find out how to grow your technical career or change your careers if you want to be a chef, right?
Right.
So I think that's. I think the other one is that the colleagues you work with in these projects become lifelong friends and people that influence your ways of thinking about the world. So if they're hardworking, generous, humorous,
Right.
that has a huge impact on your model. So if you worked in a good company,
Right.
You certainly detect it when you're in one with a less positive culture. And I
Right.
think it's very important to avoid toxic cultures or find your way out of them quickly.
Right.
Don't look to be a survivor. I can learn something here. I can,
Right.
basically, it's life is short enough. Move on. Find something where the people share your values and your passion.
Right. Right. No, very, very true. Very true. Very well said. Dave, that brings us to a close. Thank you so much for your precious time. I really enjoyed the conversation. Thank you for your being patient with me and helping me do this podcast and answering the questions. I really enjoyed the conversation and the depth and the insights and the wisdom that comes from your answers clearly speaks. Thank you so much. I appreciate be doing this. Thank you so much.
Thank you very much. I enjoyed it, and I wish you all the best. And please stay in touch.
Yeah, absolutely, Dave. I will. Yeah. Thank you. Good night.
Take care.